The post office will not accept a package whose combined length and girth is defined as perimeter of a cross-section perpendicular to the length, exceeds 84 inches. What are the length and the girth of a cylindrical tube of largest volume that can be mailed? All right, so I think the place to start with these questions is, what are we trying to maximize or minimize? That usually comes last. So we are trying to, what are the length and girth of a cylindrical tube of largest volume? So we're trying to maximize volume. That makes it harder for you to see. Maximize volume. So we're going to need formula for a volume of a cylindrical tube. What's the formula for volume of a cylindrical tube? What is it? 4/3 pi r squared h. And is that one you've memorized, or did you look it up somewhere? That one you've memorized. Very good. What would you do if you haven't memorized it? True. Where would you look it up? In the back of the book. If this problem were given to you on a test, I would give you that formula. I would not expect you to memorize all the volume formulas and such. All right, so that's what we're trying to maximize. It's tempting to say, well, let's see, I want to find a maximum. That means I need to take a derivative. I really can't take a derivative yet. Why not? I've got too many variables. I've got two variables over here. So I need another equation, and that's the restriction that they give us. I need some sort of restriction that allows me to get rid of one of these variables. So I've got to go back and read the problem. What's my restriction? 84 inches. So what cannot exceed 84 inches? So we need the perimeter of a cross section. That gives the girth. So if you're looking at a cylindrical tube like this, here's a cylindrical tube, what's the girth?
Circumference.
It would be the circumference of the circle.
I was thinking diameter for some reason.
Nope, because it says it's the perimeter. It says girth is the perimeter of a cross section. So we're looking at the circular part. All right, so we need the length and girth to be 84 inches. So we need our restriction. Our length is h, right? That's the height of our cylinder, plus 2 pi r. Circumference of a circle is 2 pi r?
Yes.
I agree. And that has to be no more than 84. Well, if we want to send the biggest box possible, I'm going to guess that I want that to be exactly 84. If that's smaller than 84, I'm going to get a smaller box, I would assume.
So why is it 2 pi r? It's not asking for just like the length across. It's asking for...
Right, because what it's asking for, if this is my cylindrical thing, this is the length. The girth is the perimeter of the cross section. So the girth is the circumference of the circle that the cylinder makes. That's what the definition of girth is the perimeter. Okay, so does that restriction formula allow me to get rid of one letter or the other? Do you want to get rid of H or do you want to get rid of R? You can get rid of either one. Which one looks easier? Looks like it would be easier to write H equals 84 minus 2 pi r. And then we're going to take that and we're going to plug it into our volume formula. So we get our formula for volume. Volume is 4/3 pi r squared times 84 minus 2 pi r. And that's how almost all of these optimization problems are going to work. You're going to start by wanting to find the maximum or minimum of something, but it's going to have multiple variables. You're then going to have to go through and look at what your restrictions are, And your restrictions should allow you to do a substitution and get rid of one of the variables that you can't use. All right, so now we got our formula for volume. Now that we have our formula for volume, what do we need to do? Find the derivative. And then what do we need to do? Set it equal to 0 to find the critical numbers. Min, max, eventually. All right. I think in order to take the derivative here, I think I'm going to do this. I'm going to write v as 4/3 pi. I think I'm going to write this as 84r squared minus 2 pi r cubed. So I think I'm just going to distribute that r squared through. And I think that makes it a little bit easier. Why does it make it a little bit easier? I don't have to use which rule? I don't need the chain rule. I never needed the chain rule. But the way it was written before, I had r squared times 84 minus 2 pi r. I needed the product rule the way it was written. So I think it's easier to take that r squared and distribute it through, and then I don't need the product rule anymore. Because this 4/3 pi, that's just a number, isn't it? All right, so volume, the derivative of volume is, v prime is, that 4/3 pi is just going to be there. And then I take the derivative. What's 84 times 2? 168r minus 6 pi r squared. So there's my derivative. Now I need to take the derivative, set it equal to 0. 4/3 pi times 168r minus 6 pi r squared equals 0. How do I solve that equation? I can divide both sides by 4/3 pi because 4/3 pi is just a number. Okay? When I divide on the right-hand side, 0 divided by anything is 0.
So why didn't 4/3 pi go away? Because isn't the derivative of the number just 0?
Yeah, well, the derivative of a number is 0, but remember this number was multiplying the letter r. Just like the 84 didn't go away because it was multiplying. Had it been 4/3 pi plus the rest of it, and then it would have gone away. The derivative of that would have been 0. Correct. I can factor out an r. R times 168 minus 6 pi r equals 0. This one gives me r equals 0. And this one, let's see, 168 minus 6 pi r equals 0. R is going to be 168 over 6 pi. Because I would subtract the 168 on both sides and I would divide by negative 6 pi. So I have two critical numbers, correct? I got to cross out r equals 0. R equals 0 is not a critical number. Can you have a cylindrical box with a radius of 0? No, 0 is not in the domain of this problem. So we really only have one critical number, 168 over 6 pi. What's left to do? Draw a number line. Why do I need to draw a number line? Check what? I need to use the first derivative test, or I could have used the second derivative test if I wanted to. And what do I need to prove? I need to prove that this critical number that we have truly generates a maximum. What's my favorite number smaller than 168 over 6 pi? R is the radius. If this is our cylindrical box, R is the radius of the circle. And if R is 0, then I don't have a box, do I? So in this problem, R could not be a negative number either. Wouldn't make any sense. Okay, what's my favorite number smaller than 168 over 6 pi? I cannot use 0. Why not?
Because it's not in the domain.
It's not in the domain. So 0 would be my favorite number, but I'm not allowed to use it. It's not in the domain. So let's use 1. All right, I'm going to plug 1 into my derivative. Here's my derivative. I'm going to have 4/3 pi. Then I'm going to have 168 minus 6 pi. 168 minus 6 pi, is that a positive number or a negative number? Positive number. So I have positive times positive, increasing there. Favorite number bigger than 168 over 6 pi? I can't use 1,000. Why not? It's not in the domain. In fact, what's the biggest possible number for R? Well, it would even have to be smaller than 84, wouldn't it be? Because if R is 84, then I'm going to have 84 times 2 pi plus h equals 84. That can't happen either. It actually has to be smaller than 84 over 2 pi. So I need a number bigger than 168 over 6 pi, but smaller than 84 over 2 pi. 10? 10 works? All right. So I plug 10 in. I have 168 times 10 minus 6 times pi times 100. That's going to be 600 there. So that's going to be 600 pi. This is 168 times 10. That's 1680 minus 160 times pi. That's about 1800 because pi is about 3. So 1680 minus something that's about 1800 is negative. Which is happy because I wanted it to be decreasing there because I wanted to make sure I had a maximum. Okay, I think we're almost done with this problem. I think there's still one more thing to do. What are the length and girth? Did I find the length and girth? No, what did I find? On the radius. So if I know the radius, can I find the length and the girth? Yes. So the girth would be 2 pi r. So that would be 2 pi times 168 over 6 pi. 168 over 3. And then I can find the height by using this formula back up here. Height is 84 minus 2 pi r. Height is 84 minus 2 pi r. So that's going to be 84 minus 168 over 3. Whatever that is. Grab your calculator, type it up, get an answer. Questions on that one? How would I have done it using the second derivative test? Okay. I would have found r to be 168 over 6 pi. And then if I want to determine if r is a minimum or a maximum, and I want to use the second derivative test, I need to find the second derivative. So I would go back here to my derivative. Oops, you can't see it. I would go here to my derivative, and I'd have to take the second derivative. V double prime would be 4/3 pi times 168 minus 12 pi r. That would be the second derivative. And then what would I do with the second derivative? No, I would not set it equal to 0. That would tell me where the inflection points are and where it's concave up, concave down, but that's not what I'm trying to do. How does that second derivative test work? I take the second derivative, and what do I do with it? I plug in my r value. I plug in 168 over 6 pi. So V double prime at 168 over 6 pi would be 4/3 pi times 168 minus 12 pi times 168 over 6 pi. Would that be a positive number or would that be a negative number? Well, the pi's cancel out, don't they? 12 over 6 is 2. So that's 168 minus 2 times 168. Is that a positive number or a negative number? 168 minus 2 times 168? Negative. Negative number. That's a negative number. Since my second derivative is negative, what does that tell me? It tells me my graph is concave down, so it looks like an upside down U, which tells me I have a maximum. When the second derivative is negative, that would tell you you have a maximum. So if I wanted to use the second derivative test, that's what I would have to do for that problem. I think this is a pretty good example of neither test was all that easy. The first derivative test was kind of a pain in the neck because we had to be very careful of our domain. Second derivative test, it wasn't very hard to take the second derivative, but then again the numbers are kind of ugly, plugging them in. Wasn't so great. Other questions? All right, what's number 3 got to say here?
I have a question about we have Monday, Tuesday off for Columbus Day.
We do have Monday and Tuesday off for Columbus Day.
And so the tests that we do, they're going to throw that out.
Nope, it'll work out just right. So we will have a test.
Planned it ahead of time.
It seems that way. I didn't. It just turned out that way. Our next exam, covering Chapter 3, will be 1 week from tomorrow. No, tomorrow's Thursday. Tomorrow's only. I wish tomorrow was Friday, but tomorrow's only Thursday. A whole another day to go. When will the lab be due? That's a good question, since we don't have class on Tuesday. No, it should still just be 2 weeks. You can do that lab at home. You should be working on that lab now, because that lab is a very good review sheet for your test. The problems on the lab are much harder than what you'll see on your test, but you get to use Wolfram Alpha on the lab. You don't get to use it on the test. So the lab will still be due 2 weeks from yesterday. Number 3. A wire of given length can be used to make a circle or a square, or can be cut into 2 pieces to make both a circle and a square. How much wire should be used for the circle if the total enclosed area is to be minimum? What if the enclosed area is to be maximum?
What?
You have to find out what the minimum value it can be is, and then it wants you to find out what the maximum value
How do you do that without any numbers?
How do you do that without any numbers? All right.
We just make some numbers up.
And make numbers up.
No, you use the formula.
Okay. There's a formula? Which formula? All right. Well, okay. A wire of given length. So apparently we're given a chunk of wire. And apparently they didn't tell us how long the wire is. So apparently it doesn't matter. So you have 2 choices. You can call your wire length L, if you wish, and deal with the letter L everywhere in this problem. Or you can say, I'm just going to give it a number. How long do we want our wire to be?
L.
L. Okay, we'll leave it with L. Fine. How about 2? Oh, I like L. So number 3. We have a wire. And this wire has length L. We have 2 choices. We can take this wire and we can bend it and make a square. Or we can take this wire and bend it and make a circle. Or we can choose to cut the wire and make both a circle and a square. So I guess we have 3 choices, actually. We can...
Doesn't ask about the square on the unit, so we have to.
What's that?
The A and B, it doesn't ask about the square.
You only have 2 choices because we can't use the one about just the square.
Well, but it says, a wire of given length can be used to make a circle or a square, or it can be cut into 2 pieces and make both a circle and a square.
Yeah, but A says how much wire should be used for the circle if the total area is minimum and
There's always
Correct. So it's asking you, how big should you make the circle and how big should you make the square?
But what if, yes, actually, what if this just making the square is the smallest to the largest? That means that the circle would be 0, right?
That's a possibility. It's possible that the correct answer is don't cut the wire at all. It's possible the correct answer is just make a square. Or it's possible the correct answer is just make a circle. Or it's possible the correct answer is cut the wire somewhere and make both, and that's how you'll get your maximum area or your minimum area. We don't know yet. All right, so we have a wire of length L, and we're going to cut it somewhere. I'm going to cut it right there. I'm going to use this left-hand side to build my circle. So this left-hand side, I'm going to call this length right here X. And I'm going to use the left-hand side to build my circle. If that length is X, then how long is the other piece? Y would be a correct answer, but I don't want to introduce more variables if I don't have to.
L
L minus x. It would be the total length minus what we've cut off. So I'm going to use that piece over there to build the square. All right, so what am I trying to find again?
How much wire should we use for the circle of the tone for this area?
So we want to, in part A, we want to minimize the area. In part B, we want to maximize the area, right? Okay, so I need a formula for area. How do I find area of a circle? Not 2 pi r squared. Just 1 pi r squared. Pi r squared. Plus, how do I find the area of a square? S squared, where S is the length of a side. Again, I have too many variables here. I have R, I have S. I think what I want to do is I think I want to convert both my variables and use the letter X. Because it asked me, how should I cut the wire X to make my circle? So I really want to find the length of X. Let's start with a square, because that one's easier. I've got a wire of a certain length, and I'm going to bend it to make a square. If I bend this wire to make a square, how long is each side going to be? L minus x over 4. Okay, so area is going to be something plus L minus x over 4, all squared, correct? The length of one side, I got to bend it into 4 equal lengths, basically. So the area will be L minus x over 4 squared. All right, this one's the harder one, I think. Now I have a wire of length x, and I want to bend it to make a circle. How big does my radius have to be? X over 2 pi. Why x over 2 pi?
Well, x represents the circumference, so we can set that equal to 2 pi r and solve the problem.
Excellent. When we take this wire and we bend it, when we bend this wire to make the circle, that's actually going to give us the circumference of our circle, isn't it? So I know that 2 pi r has to equal x. So the radius of that circle has to be x over 2 pi. So the area of my circle is going to be pi times x over 2 pi squared. All right, so I'm going to do a little bit of simplifying here before I find my derivative. A equals, I'm going to write this as pi over 4x squared. How did I get, nope, that's not right. How did I get that? I made a mistake. That's how I got that. How about A equals 1 over 4 pi x squared? How did I get that? I simplified. X squared is x squared, right? On bottom, I would have 4 pi squared. And I canceled one of the pi's. So I got 1 pi left in the bottom and the 4th left in the bottom. And then over here, I think I'll just write this as 1/16 L minus x squared. Well, I squared the 4. 4 squared gives me 16. But I still need to square the L minus x. All right, so I think there's my formula for area. Now what? Derivative. A prime. Okay, so you're saying we have multiple variables. It looks like we have multiple variables, don't we? But we really don't. Why not?
Because L is the original length of the wire, and X is just what the cut in half wire.
L is the original length of the wire. Is the original length of the wire changing at all? No, it's some fixed number. X can change depending on where I choose to cut the wire. But L itself is just a number. We don't know what number it is. Yes, you're right. Math is case sensitive. I should not be mixing my cases. Correct. Okay, so I agree. This formula is a little misleading. It looks like L is a variable, but it's not. L is some fixed number. We don't know how big it is. It might be 2, it might be 1,000. We don't know, but it's some number. Doesn't really matter what the number is. We could call it constant. We could have called it K for constant or C for constant. I guess constant starts with C. I called it L for length. But any letter other than X would have been okay. Derivative. I bring the 2 down. I have 1 over 2 pi X plus 1 over 8 times L minus X times negative 1. Where'd that little negative 1 come from? I had to use the chain rule there, didn't I? I had to bring the 2 down, subtract 1 from my exponent, and then I needed to multiply by the derivative of the inside. That's where that negative 1 came from. Now what? Set it to 0 to find the x value, to find the critical number. All right, 1 over 2 pi x minus, I'm going to do a little distributing here, minus 1/8 L plus 1/8 x equals 0. How do you solve that equation? Wolfram alpha. I didn't bring it with me. That's a lie. I do have it actually. But what? Move the L over? Okay. So 1 over 2 pi x plus 1/8 x equals 1/8 L. That's a good move. Get all the x's on one side, all the things without x on the other. Factor out an x. You know what I'm going to do? Factoring out the x is correct. And then after you factor out the x, what would you do? You would divide by 1 over 2 pi plus 1 over 8. And that sounds kind of ugly to me. I think I'm going to take this whole equation and I'm going to multiply everything by 8 pi. It's going to get rid of all the fractions for me, isn't it? And what happens when I take 8 pi and multiply it by 1 over 2 pi x? That's 4x, isn't it? 4x plus, what's 8 pi times 1/8 x? Pi x equals pi L. Yeah, so that just cleans it up a little bit. Hi Ray, just here to listen to the music. Alright, we factor the x out. X times 4 plus pi equals pi L. So x is pi L over 4 plus pi. So there's our critical number. All right, I got a question for you. We were supposed to find both the minimum and the maximum, weren't we? How can we find both the minimum and the maximum if there's only one critical point? No, x is a distance, remember. X can't be positive and negative, it can only be positive. Would x equal 0 be something interesting? Remember what we're doing here.
Yeah, because x equals 0, then 1 part 0, and then you still have L minus x. So if x is 0, then you still have the length.
If x is 0, I still have the length, which means I'm not building a circle at all, and I'm just building a square. Is that possible? Are we allowed to do that? Yes. So we also need to be concerned about x equals 0. Similarly, x could be L, couldn't it? If x equals L, what does that mean? You're just building a circle and you're not building a square at all. So, this is one of those problems that's more like section 3.1, where what we really need to do is build a table. X could be 0, x could be L, those are the endpoints of our domain. And they are in the domain this time. The previous problems we've done, we said x can't be 0. But this time x really can be 0. And then we need to plug in pi L over 4 plus pi. We'll pick the biggest one, we'll pick the smallest one, and that'll be our minimum and our maximum. Alright, so I'm going to go back up to my area formula. And I'm going to plug 0 in for x. If I plug 0 in for x, I get 0 there. And here I would get 1/16 L squared. Okay. Now I'm going to go back up to my original area formula. And I'm going to plug in L. If I plug L in, I get L squared over 4 pi plus 0. L squared over 4 pi. Of those two things, which one's the bigger one? The second one is bigger? Why is the second one bigger? So at the bottom here is 12 point something, something, something roughly. And this one's 16. So this one has a bigger bottom, which means this one's a bigger number because we're dividing by less. Okay? Now comes the fun one. Plug in 4 pi. Oh, no, I would be happy if I got to plug in 4 pi. I got to plug in pi L over 4 plus pi and back up into my original formula. Back up into the original, right there. I got to plug in pi L over 4 plus pi. And then I've got to be able to simplify it enough to decide if it's bigger than this one or smaller than that one or what the heck's going on. Who assigned this problem? Geez, I don't know. All right, well, I guess there's no avoiding it, right? We're going to have 1 over 4 pi times pi L over 4 plus pi. All that is going to be squared. Plus 1 over 16 times L minus pi L over 4 plus pi squared. Holy crap. What do you do? Wolfram alpha. Can we do it by hand? Probably. Oh, well, let's see. This is 1 over 4 pi times pi squared L squared over 4 plus pi squared plus 1 over 16 times, all right, here I need to get a common denominator. So this is going to be, I'm going to write L as L times 4 plus pi over 4 plus pi. And then I got to subtract it to this thing over here. So look what's going to happen. You're going to have a 4 pi here. You're going to have a 4L here. And you're going to have a pi L here. But you got a minus pi L there, don't you? So those are going to cancel out. And what are you going to be left with? 4L over 4 plus pi. And that whole thing is squared. What's that? Well, all I did was I was taking this L right here, and I wanted to combine it with this fraction. So in order to do that, I needed to get a common denominator. So I'm thinking of L as being L times 4 plus pi over 4 plus pi. And then when I multiply this L through, I'm going to have a pi L over here, but then I'm going to have a minus pi L. Those are going to cancel out. So that's kind of nice. So far. Well, let's see. Let's see what else we can do. Maybe we'll get lucky and things will cancel and we'll end up with something nice. Let's see. I can cancel this pi with that pi, can't I? I don't see much else I can do, though. That's 1/4 pi L squared over 4 plus pi squared plus L squared over 4 plus pi squared. Because 4 squared is 16, so that's going to cancel with that. Am I getting anywhere? You sure? That's what? Well, they don't have the same denominator, do they? Because this one has a 4 on bottom. So what do I need? I need to put a 4 on top and a 4 on bottom of that one, don't I? To make the common denominators. So that's going to be, on top I can factor the L squared out. And what do I have left when I factor the L squared out? Pi plus 4 over 4 times 4 plus pi squared. But then I can cancel that with one of those, can't I? Alright, so I'm left with L squared over 4 times 4 plus pi. Wow, that was a lot of work. L squared over 4 times 4 plus pi. Now, we have to decide, of all these answers, which one is the biggest and which one is the smallest. You're telling me this one is the largest? Because notice they all have L squared on top, L squared, L squared, L squared. So all we really need to do is look at the bottoms. This one has 16 on bottom. This one has about 12 on bottom. And this one has 16 plus 4 pi. So this one has the biggest bottom, which means this one is the smallest. This one has the smallest bottom, which means this one's the biggest. So here we have our absolute max, which means if you want to build the biggest possible area, don't cut the wire, just build a circle. If you want the biggest possible area, build a circle. And this one would be the absolute minimum. You're going to build a circle and a square, and you're going to cut your length of wire at x equals pi L over 4 plus pi. Good luck measuring that. Not a very nice number. Questions on that? Geez, I hope not. I haven't written the test yet, so I don't know. But that one seems a little difficult for a test question.
Unless you make that the old cut.
Even if it's the only question on the test, I think that's a little difficult for a test question.
Yeah.
All right, let's take a look at number 4 here. We might not have time to finish number 4. Get it started. Well, I'll get started today and we can finish it tomorrow. I'll put it right back on the piece of paper. I'll save my notebook so we can see it tomorrow. All right, number 4 says, a powerhouse is on one edge of a straight river and a factory is on the other edge, 100 meters downstream. The river is 50 meters wide. It costs $10 per meter to run electric cable across the river and $7 per meter on land. How should the cable be installed to minimize the cost? Okay, well, here's the general picture. You've got a river. Nice and straight. And the river, it told us, is 50 meters. Here, we have power. We have a power plant here. And over here, we have a factory that needs electricity. And it's 100 meters down the river. So the question really is, how do we lay the cable to minimize the cost? One possibility is we simply lay the cable diagonally right across the river like that, correct? What's another possibility? You go all the way down the river and then straight across. Or the third possibility is you come down somewhere in between and then go diagonally across.
But you could cross immediately and go that way, but that would
Well, if I were to come across here and go straight across and then go that way, that would be the same as doing this.
yeah.
Or you're correct. I think what you're saying is you could cross immediately and then go down. But I think that would be the same as this because you would still have the same length here and still the same diagonal. So it doesn't matter if you cross immediately and go down or if you go down for a while and then cross. I think the cost will be the same. Okay, so let's find some of the costs here. We'll do the easy two. Let's find the cost of going all the way down and then across. So cost could be, if I go all the way down, how much is it going to cost me? Well, it says it costs on land $7 per meter. So if it's $7 per meter and it's 100 meters, that's going to be $700. Plus, to go across the river, it's $10 per meter. So that would be 10 times 50, which would be 500. So it would cost $1,200 to go all the way down the river and then straight across. What if we decide to just go this way? Then we're not laying any cable on land, are we? We do the Pythagorean theorem. So we would have, I'll call that C, I guess. C squared would be 100 squared plus 50 squared. So C would be the square root of that. 1118. We'll just call it 1118 then. 0.03. I'm not going to worry about 3 centimeters. Not 3 centimeters, by the way, but that's okay.
Well,
so cost would be.
That's the cost. It's, so because the 111.803 is the C itself, and since it's going across the river, you multiply that.
So we take 100 and
Then do just 111.8.
we multiply by.
The C he gave you is the cost already.
Oh, that's the cost already.
Yeah.
Oh, okay, I see. I thought that was just the C distance, the length. Okay. So I see what you're giving me. The cost would be this length when you take the square root, and then you multiply it by 10. Well, that's cheaper.
Why do you multiply by 10?
Because it costs $10 per meter to lay the cable in the water. So that's cheaper. That's better, right? We saved $72 roughly. All right, so tomorrow we'll come back and we'll decide, should we stop somewhere in the middle and go diagonally and see if we can make it cheaper still. See you tomorrow.